Adjunct Professor Moran, Microeconomics 112. In this session, we're going to demonstrate that for an imperfect competitor, marginal revenue equals marginal cost will result in the best outcome of the firm, either profit maximization, loss minimization, or shutting down. Price will not result setting it equal to marginal cost for the best outcome. If you remember, for a purely competitive firm which had a perfectly less demand curve, because of the assumptions of what purely competitive industry is, an infinite number of identical firms all selling at the same price, which is given from the market, price equals marginal revenue. We demonstrated this with this demand curve and the resulting total revenue curve. But a monopolist actually sees the downward sloping demand curve of the industry. The firm equals the market. So to sell more, he's got to charge less, or to charge more, he's got to sell less. To sell more, he's got to price less. To sell at a higher price, he's got to sell less. That's going to result in a difference between price and marginal revenue. At any price quantity combination, marginal revenue will be less, except for the first unit. Price, marginal revenue at 5. Price, marginal revenue at 9, for example. There's a gap between price and marginal revenue. So we're going to demonstrate that the best outcome happens at marginal revenue equals marginal cost, as opposed to price equals marginal cost, because this identity is no longer true. Monopolist. Then we're going to demonstrate that that price quantity combination does not occur at total revenue max, because total revenue max does not occur at profit max. And we're going to demonstrate that profit max always occurs in the elastic range of a demand curve, which we mentioned here. Let's start off with demand curve, price, and quantity. Notice that as price goes down, quantity goes up. Total revenue is price times quantity. Marginal revenue, since this is increasing by 1, we don't have to worry about dividing this by the prior change. It's just the prior amount subtracted. 304 minus 162, 426 minus 304, 528 minus 102. If we assume our average total cost are these numbers, notice there is no average total cost at 0, which means this firm has no fixed cost. A review of prior material. Okay, our total cost is our average total cost times quantity. If we take our total revenue, price times quantity, subtracting our total cost, average total cost times quantity, we can determine profit. We can also then determine marginal cost by subtracting prior total cost from current total cost. Now, we know that the elastic range is where a price decrease leads to an increase in total revenue. Where price and total revenue move the opposite way, it's elastic. Where price decreases and total revenue decreases, that's the inelastic range. Let's look at that and define each. Here, price is falling and total revenue is increasing up to 9 units. But when price falls further to 72, total revenue falls to 720. That means 1 through 9 is the elastic range, and 9 to 10 is the inelastic range of a demand curve. Okay. Now, notice that if we lower the price to 162, they sell 1 unit instead of no units, and our profit rises to our loss falls to 28. Oh, we do have a fixed cost here at at no units of output, our total cost is 100, so they have a total fixed cost of 100. At 2 units of output, our profit rises to 38. At 140, at 3 units, our profit rises to 87, which is total cost minus total revenue minus total cost. 4, we have a profit of 128. At 5, we have a profit of 140, so it's been increasing. But at 6 units, we have a profit of 122, meaning we're profit maximizing at 140. Notice that if we compare marginal revenue to marginal cost, where marginal revenue is greater than marginal cost, our profit is increasing. But where marginal cost is greater than marginal revenue, our profit is decreasing. So the decision rule is marginal revenue is greater than or equal to marginal cost to profit maximize. Here, at these amounts, our profit is falling where marginal cost is greater than marginal revenue. Notice that the change in price has nothing to do with our profit maximizing level of output. So now I hope you are convinced that marginal revenue equals marginal cost, or marginal revenue equals marginal cost if they are never exactly equal, is the one that will result in the best outcome for the firm: profit maximization, loss minimization, or shutting down. Notice that this price-quantity combination happens in the elastic range of the demand curve, not the inelastic range. Total revenue maximizes here, but profit maximization happens here. So profit max and total revenue do not occur at the same quantity of output. Let's graph this and look at the relationships. Here's the price quantity combination. Price quantity. If instead we graph quantity with marginal revenue, we'll get this graph. Notice that at each price quantity or marginal revenue quantity, marginal revenue is less than price. Price greater than marginal revenue at each level of output except the first, where they're equal. That's why marginal revenue is lower than price. When marginal revenue is 0, total revenue is maximized. It doesn't exactly happen here, but it happens at close to 9 units at $82. 9 units at $82, marginal revenue is 2. Close enough to 0. Notice that marginal revenue is falling as price, as quantity increases. But to sell more, the firm has to reduce its price per unit. Now, although it's reducing its price per unit, and its marginal revenue is going down, these numbers are still positive, meaning its total revenue is still rising. As long as marginal revenue is positive, total revenue is still rising. Here we have price quantity, price given quantity, and marginal revenue quantity. Here we have total revenue on this axis given quantity. So we're graphing two different things on two different graphs. Total revenue and quantity on this lower graph, marginal revenue and price on the top graph. When marginal revenue is 0, total revenue will be maximized. Even though these numbers are getting smaller, they're still positive. Marginal total revenue will be rising. But when marginal revenue is negative, then that means your total revenue will be falling. Okay. Why is that? If your marginal revenue, if the extra amount of money you could get from making one unit is 162, and it only costs you an extra 90 to make it, would you do it? Remember that marginal means next. If you make your next one, which is 2, and it costs you an extra 80 to make it, but you could make an extra 304 from selling it, 142 from selling it, well, then you'd be $62 better off, and you would do it. The third one, your marginal cost takes you an extra 69 to make it, but you could sell it, make an extra 122 from selling it, you'd be better off. Your marginal revenue would exceed your marginal cost, and you would make this one. At 4 units, your marginal cost is 61, your marginal revenue is 102. So your profit is rising. At your 5th unit, your marginal revenue is 82, your marginal cost is 70. You're adding $12 to profit. You're adding less per unit, but these are still positive numbers. So you would make it and maximize profit at 140 the last time which marginal revenue is greater than marginal cost. But at the 6th unit, your marginal revenue is 62, and your marginal cost has risen to 80 because of the principle of diminishing model returns, which was discussed in the session we discussed costs in. Here, you're $18 worth off. Your profit has fallen $18. So you're going to produce profit maximization will happen when marginal revenue is greater than or equal to marginal cost. Here at this unit, your marginal revenue is less than your marginal cost. You're reducing your total profit. This is the decision criteria. So, marginal revenue bottoms out at 9. Your total revenue maximizes at 9. But the firm won't produce 9 because although its total revenue is maximized at 9, its total profit is maximized at 5 at $122. 5 units, 122, profit maximized of 140. The firm wants to maximize total profit, not total revenue. Now, notice that this combination of price quantity happens at 5. That's in the elastic range of a demand curve. The elastic range of demand curve is where a decrease in price increases total revenue. A decrease in price increases total revenue. Where price decreases and total revenue goes down, that's the elastic range. So we don't know where in the elastic range that's going to occur, but we know that this price quantity combination will always happen in the elastic range because this is negative slope and this is a negative slope and this is lower than that one. This one will always hit 0 over here. So the price quantity combination has to be in the elastic range. The monopolist or imperfect competitor will always price in the elastic range of a demand curve because profit maximization versus total revenue maximization occurs in this range. Unitary elasticity, total revenue is maximized. Inelastic range, where a further decrease in price will result in lower total revenue. Profit maximization and total revenue maximization do not occur at the same amount of output. Profit maximization in the elastic range, total revenue max, profit max happens someplace in this range, not in the inelastic range, where marginal revenue has turned from 0 to negative. In our next session, we'll begin to graph. We'll add costs and graph these and see how we can determine the optimal price quantity combination resulting in profit maximization, loss minimization, or shutdown will be revealed.